In this example, we want to find the complex zeros of the polynomial f. In this particular example, we're not going to go through the normal steps where we find possible rational zeros and use synthetic division. I'll give you a hint. In this example, all four of the zeros are imaginary. So to attack this problem, we're actually going to do a u substitution. Recognize that it can be written in quadratic form if we let u equal x squared. So we can rewrite this as u squared plus 13u plus 36. And then we'll set that equal to 0. And we can factor the quadratic now. Two numbers that multiply to 36 and add to 13 are 9 and 4. We'll then set each of these equal to 0. We get u equals -9 and u equals -4. We'll back substitute. We said earlier that u is x squared. So we have x squared equals -9 and x squared equals -4. Finally, we take the square root of both sides to solve for x. And we get that x is equal to plus or minus 3i, and x is equal to plus or minus 2i. Next, we'll actually do part C. We'll write f of x in factored form using the complex numbers. We have x minus 3i, x minus -3i, which will make this plus 3i. And then we have x minus 2i, and x minus -2i, which is x plus 2i. We now have the factored form over the complex numbers. If we want to factor this over the real numbers, we need to distribute these first two sets of parentheses. That will give us x squared plus 9, and then distribute the next set, x squared plus 4. We now have the polynomial factored over the real numbers.